Hi everyone, this is Maths for Uni, and this is the worked solution to question 5 from the worksheet for lecture 2 from our online Udemy course, of which the link is in the description. If you find this content helpful, then please consider liking and subscribing. So first, let's take a look at the question. It says, prove by contradiction that the sum of a rational number and an irrational number is irrational. So, what exactly does that mean? That means if we take r, which is an irrational number, which we can write as all of the real numbers set differenced with all of the rational numbers, and then say we have a rational number which we can write as p over q, where p and q are integers and q is not 0, then we look at the sum r plus p over q. We want to show that this is irrational. So for a contradiction, let's start by assuming that it is rational, i.e. it's equal to s over t, where s and t are integers and t is not 0. Notice in the above, for p over q and s over t, we've written p and q, s and t are integers, and q and t are not 0. In the video, we further assumed that p, q were co-prime, for showing that root 2 is irrational. But here, we won't need that assumption, because in the video, we use that assumption to contradict. But for now, we have r plus p over q equals s over t. So how exactly are we going to contradict this statement? Either one of our original assumptions will do, i.e. that r was irrational or that p over q was rational. In this equation, in some sense, we know less about this irrational number r. And so, if we rearrange this equation to make r the subject, then we might learn more about r. So that would be s over t minus p over q, and then we could combine these fractions into one overall fraction by using cross multiplication. So we have sq minus tp all divided by tq, and this gives us one fraction altogether. However, what exactly have we written here? We have this irrational number here, but we have this fraction here of integers, i.e. a rational number. So we have shown that in fact r is rational, but earlier we assumed that r was irrational, and therefore this is our contradiction. Potentially, it's easier to see this in words. We start with the sum of our irrational number and our rational number, and then if we assume that it's rational, we could rearrange the equation to get r being equal to a rational number. Therefore, we get our contradiction, and so therefore we have shown by contradiction that the sum of a rational number and an irrational number is always irrational. Here's something to take away to think about from this video. What can we say about the sum of two irrational numbers? Is it always irrational, or potentially not for certain irrational numbers? If you found this content helpful, then please consider liking and subscribing, and also checking out our full Udemy course of which the link is in the description. Thanks for watching, and goodbye for now.